Thanks, Nguyen, for the introduction. And sometimes because I will speak a little bit small during while I'm talking, so if you can't hear me, just raise your hand and I will try to speak louder. So today I would like to give like a very brief talk covering from fire safety engineering through to behavior of construction materials with some focus on the nanocomposite that we have been developing at Melbourne Uni here. And we also present some of the computational fluid dynamic simulation that we are working on how to improve the building performance and evacuation strategies, like what should we do when there is a fire in the building? Should we just grab a chair and jump out of the window? Coming to fire safety engineering, so far it is not a new thing. You know, ancient people, they knew how to create a fire with even sticks and stones. But even now, in a modern world, we have tall high-rise buildings, we have mega cities, but we're still struggling to control the fire properly. For fire safety engineering, if we're coming back to the history of fire safety engineering, even all around the world, it is all about how we learned from the fires that actually happening, and how we change from prescriptive based method to performance-based design, which reflects in the cost and standards that we are having now. And coming to Australia, so like more than half of the National Construction Code comes from fire, but the question is, are these current measures enough? Okay, so two important components of the fire safety engineering would be the building performance and egress strategy. So basically, fire safety engineer like the building design in case of fire, it will be like the chase against time, so how we design the building to withstand the fire, and how quick we can do to evacuate people from the risk coming from fire. And it is important that we can combine those two components in the building design. So I just quickly went through a little bit about the National Construction Codes, but it will be covered later on by Jonathan. Coming to other building designs, we have different requirements for building elements, such as the AS 1530.1 and .2, and then there is another alternative method of AS 5113, but it is not quoted in the NCC at the moment. And when we have other elements like the linings or architectural element, we have AS 3837 and then AS 1530.3, but it is like small-scale fire tests, and sometimes it doesn't reflect properly the behavior of the material during fire, and this will be again covered by Jonathan later on. So coming to the second part of the behavior of construction materials exposed to fire, and we are thinking like maybe we don't have any issue with even conventional material like concrete or steel, but when it is concrete, as Jonathan mentioned this morning, even with the Grenfell fire, we still witness the failure of concrete elements during fire. Same issue with steel structural as the WTC, where the final report, they came that the building failed because of the fire, but not because of the initial crash. Yeah, Jonathan, maybe you will have further comment on this. The next part will be about the nanocomposite that we developed within the ARC linkage with Thomas de Lisa. So this project, it was led by Associate Professor Tuan Ngo, and I was involved in this project. So with this project, we had the chance to, for the first time, incorporating nano materials into the facade element instead of just using it as in the facade paint, the surface paint. And from this project, we also developed like a new fabrication method that we can actually produce this nano-composite facade at industrial scale. And just for some comparison, what will be the difference when we use nano-composite facade compared to the conventional nanocomposite ones. And the results from our work showing that with nanocomposite, it helps to prevent the flashover from flashover within the tested room, and also help to reduce significantly reduce the room temperature as well. The next part will be about the CFD simulation. We also, within this project, we try to investigate the behavior of the material from material to later on to as a building element. Based on the experimental result of the AS3837, then we figured out that if we just use traditional method of simulation, we have this result. And then we developed the first model, which has like a better agreement with the experiments, but we are not happy with that. We try to develop a bit more with the modified Kissinger-Bradford method, and we have a good model to predict the behavior of material in fire. And we was also involved in another project with a building in London. There was some requirements from the architects to design this facade element with composite, because they failed to produce it with aluminium or with steel because it was too expensive. So we try to like to develop a nanocomposite element. A composite element where it can have to pass the Eurocode EN 13501. That is the single burning item test. And also we was involved in another project with the city office in Netherlands. Again, the composite facade came, and we tried to use the nanocomposite that we developed in this project, and the results from our work showing that this nanocomposite can help to pass the requirement for class BS2D0 to be used in mid-rise building. And moving a bit away from the standard, we have like developed some other models based on the material models that we did before. For this, we will just study how the nanocomposite facade will behave with a normal furniture fire. Okay, so the next part will be evacuation. So all the other previous thing, it was about how we improve the building performance to withstand fire. But when a fire happens, like what should we do? How can we evacuate people? So the first thing, should we post that event to Facebook before we escaping from the building? Or should we just wait inside and waiting for the fire to escape first, and then we'll get out later on? For the evacuation strategy, we for high-rise structures, we took the case study of the Lotus Tower. For this project, Professor Priyan Mendes was involved in from the design to construction stage. And so when finished, this building will be, this tower will be the highest one in South Asia. And we were involved in like to investigate what will happen if there is a fire happens, for example, at the top part of the tower. These are some of the results of the agent-based models that we developed, showing the importance of using the pressurized lift staircase and increasing the number of evacuation lifts. We also got the chance to investigate like different strategies, for example, phased evacuation, and how should we combine the use of evacuation lifts and the staircase, which is just some video with high speed to show like how people will evacuate from the upper tower. And In other projects where we have the chance to work closely with Dr. Jonathan Bennett, then we are trying to take the Grenfell Tower as a case study for the evacuation strategies of mid-rise structures. This is ongoing work, and we hope we can show you some results later on when we know more about the Grenfell Tower and we have more information. That's my talk today. I hope I didn't put your head on fire. So stay tuned because more fire is coming with Jonathan.